Have you ever been in a meeting and just kind of zoned out? Like you're staring but not really seeing anything. And did your teachers ever know you were doing that in class?
Yeah.
Well, today we're going to go way beyond those little tells. We're diving deep into the world of eye tracking technology to understand what's really going on visually in classrooms.
Yeah, it's amazing what we can learn from just watching where people look. Like we've got this whole stack of research here from the Educational Psychology Review, and they're using this eye tracking tech to figure out all kinds of stuff, like how engaged students actually are, what expert teachers notice when they're observing, and even the details of those teacher-student interactions.
So it's like our eyes aren't just randomly wandering around, they're
They're
giving us away. Right. Like
Yeah.
where we look shows what we're focusing on at that moment.
Yeah, exactly.
Think about it. When you're reading something complicated, you probably linger on certain words longer, like you're trying to really get them.
Yeah, yeah. And those pauses, the fixations, that's what they're called, and those quick jumps between them, the saccades, that's where the magic happens. Like longer fixations could mean deeper processing or maybe hitting a snag, you know?
Hitting a snag. Interesting. So these studies take that link between our gaze and our thoughts and bring it into the classroom.
Exactly.
And the classroom is already a pretty complex place, even without eye trackers.
Oh yeah, there's so much going on.
So our mission in this deep dive, what we're trying to do, is extract the most meaningful insights from all this research. Like, what do these visual patterns really tell us about how learning and teaching work, from a visual perspective?
I think that's a great way to put it.
Okay, so let's start with the students. How can we use eye tracking to tell if they're really engaged?
Okay, well, first we got to define engagement, right?
What do we even mean by that?
Well, the research we're looking at defines it in a very specific way. It's basically how focused the student's attention is on the learning task. And eye movements are like a direct line to seeing that focus in action.
Hmm.
Like Miller's work in 2015, that was a really influential paper that kind of laid out this idea.
So like eyes on the textbook or the teacher or the whiteboard, that equals engagement, basically.
Yeah,
And didn't Rosengrant and their team actually test this during real lectures?
they did. They used eye tracking to categorize student behavior just based on where their gaze landed. So if they were looking at the lecturer or their notes, that was considered engaged. But if their eyes were wandering off, maybe to their phone or a classmate,
Busted.
that was classified as off task.
Off task. It's so interesting, though, right? They found that engagement isn't just this constant thing. It goes up and down throughout a lecture.
Yeah, it fluctuates.
I mean, we all know that from experience, right? We zone in and out.
Absolutely.
But it's cool to see it in the data.
Yeah, and this connects to some other research on how cognitive engagement changes, even when you're just reading.
Mm-hmm.
There are studies by Palahine, Kakinen, Hayone, all looking at this.
Yeah.
And they found that we have these little shifts in attention, like from moment to moment, as we process different bits of information.
Mm-hmm.
But we also have these bigger changes in our overall level of engagement over time.
Mm-hmm.
So it's not just one glance, it's the whole picture.
It's so much more dynamic, right, than just saying, oh, this student was 75% engaged for the whole class. It's all about those shifts in attention, those little moments.
Yeah, definitely. And then Goldberg and their colleagues, they took an even more comprehensive approach.
Oh, even more than eyes.
Yeah, they were like, let's throw everything at it. They tracked eye gaze, of course.
Right.
But they also looked at head position, facial expressions, even how synced up a student was with the people around them, in terms of movement, all to try to predict engagement.
Wow, that is a lot of data. And did it work?
It did. It was really cool. Their automated analysis, like based on all that stuff, it lined up really well with what human observers saw in the videos.
Oh, interesting.
And it even correlated with the students' self-reported engagement levels.
Mm.
So this suggests that combining eye tracking with all these other measures can really give us a deeper, more multifaceted understanding of what engagement actually looks like in the classroom.
So like different signals for different kinds of engagement.
Yeah, like eye movements might pick up those quick shifts in attention, those little blips.
Yeah.
But body language could show us a more sustained level of engagement, whether someone's really tuned in or totally checked out.
Okay, so we've talked about the student side of things. Now let's flip it and look at the teachers.
Yeah.
What can eye tracking tell us about their expertise?
This gets into the idea of professional vision. Like, how do experts see the world differently? Eye tracking has been used for a long time to study expertise in all sorts of fields like chess, radiology, and researchers like Gegenfertner, Reingold, Sheridan, they've done a lot of work in this area.
So are you saying teachers are like chess masters?
In a way, yeah. The idea is that experts in any field, they see and interpret visual information differently because they have all this knowledge and experience.
That makes sense.
And now we're applying that same concept to teaching, researchers like Beach and McConnell, Taraska, and their team. They're all exploring this.
So it's not just about knowing more stuff, it's about actually seeing the classroom differently.
Exactly.
Like Ringgold and Sheridan, they talked about how expert eye movements might show that they have better perceptual skills and also this kind of intuitive understanding, this like built-in knowledge. What is that tacit knowledge anyway, in teaching, I mean?
Well, imagine a seasoned teacher scanning the room, right? They might instinctively zero in on a student who's zoning out or who's confused, even if that student isn't like waving their hand or anything.
It's a quiet struggler.
Yeah, and it's not even a conscious decision necessarily. It's based on years of experience, recognizing those subtle cues. The slumped posture, the furrowed brow, the lack of eye contact. That's the tacit knowledge, guiding their attention to things that a novice teacher might miss.
Interesting. So it's like they're picking up on all these little things that we don't even realize we're giving away.
Exactly. They're
Right.
processing the visual information in a much more sophisticated way.
So what have studies actually found about the eye movements of teachers with different levels of experience?
Well, there's a study by Seidel and colleagues. They found that expert teachers tended to fixate more on students who seemed uninterested, underestimated, or were struggling.
So like they're noticing the kids who need help, even if those kids aren't asking for it.
Yeah, but I should mention the statistical evidence in that study was kind of weak.
Okay, so it's suggestive, but not a slam dunk.
Right.
What about when teachers are observing a more like dynamic, real-time classroom situation?
Well, Weiss and their team looked at that. They showed teachers a video with a disruptive student, and they found that expert teachers looked at that student more and for longer periods.
So they're like zeroing in on the problem.
Exactly. Especially if they consciously remembered noticing the disruption. So this suggests that expert teachers are just more attuned to and focused on managing those critical incidents in the classroom.
That makes sense. Like they're more likely to see it coming and then to really focus on dealing with it.
Exactly. They're not getting distracted by other things.
Right, right. But then there's this other study by Puda and their colleagues where they didn't find overall differences in eye gaze between expert and novice teachers during math instruction.
Yeah, that one seems to contradict the other findings.
It does, right.
Well, but if you look deeper, their results were more subtle. Both groups, the experts and the novices, they were shifting their gaze between the teaching materials and the students' faces.
So they're both monitoring the class.
Yeah. But the timing of those shifts was different. Experts did it more during supportive instruction, maybe checking for understanding when they're helping a student, while novices did it more during non-supportive instruction, maybe trying to regain attention after introducing a concept. So it's not about how much they look, but when they look.
Oh, that's a good point. It's about the context of those looks.
Right, and what those looks might mean.
Okay, so maybe expert teacher vision isn't one size fits all.
Definitely not. It depends on the situation, the task, what they're trying to do.
It's context specific.
Exactly. Just like Yorba showed in his classic work, our eye movements are driven by what we're trying to accomplish. And Gegenfertner and his colleagues, they also emphasize this, that visual expertise is often very domain-specific.
Like a teacher might focus on different things when they're evaluating student work versus when they're leading a discussion.
Exactly. It could be about a wider visual scan sometimes, like Ringgold and Sheridan suggested,
Taking it all in.
or a very focused attention on specific things, like Wolf and their colleagues proposed.
Okay, so different strategies for different situations. And speaking of Wolf and their colleagues, they have this model, the classroom management scripts idea, right? How does that connect to eye movements?
Oh, that's a fascinating model. The idea is that experienced teachers, they develop these mental frameworks, these scripts, for common classroom scenarios.
Like, if this happens, then I do that.
Yeah, exactly. And these scripts, they help them anticipate problems and automatically direct their attention to the right cues. Like, imagine a teacher during group work. They might have a script that involves quickly scanning for signs of collaboration or confusion, guiding their eye movements without even thinking about it.
So it's like a mental shortcut.
In a way, yeah. It helps them be more efficient. And this could explain why their gaze patterns might look different from novice teachers who are still consciously processing everything.
So maybe you could actually train novice teachers to develop these visual scanning patterns, like to be more like the experts,
That's a great question.
like eye tracking training for teachers.
Yeah. And Ringgold and Sheridan, they actually suggested using something called gaze contingent display paradigms to study this further.
Gaze contingent display paradigms. That sounds complicated.
It is a bit, but basically, imagine a screen where what you see is linked to where you're looking.
So, like, if you don't look at it, it disappears.
Yeah, something like that.
Tricky.
By manipulating this, you could test whether experts really do have a wider field of vision or if they're just better at rapidly focusing on the most important information.
I see. So if you restrict their view, they might be more thrown off than a novice.
Exactly. It could be a way to really isolate those underlying visual processing differences.
Okay, so we've looked at students and teachers separately. Now, what about when they interact? How does eye tracking help us understand those dynamics?
This is where it gets really interesting. Puta and colleagues, in that same study on math instruction, they also used mobile eye tracking to look at teacher-student interactions.
So they can move around.
Yeah, they weren't tethered to a computer. And they found that experienced teachers had more gaze shifts between the materials and the student's face during supportive instruction, like when they were helping a student with a problem.
Checking for understanding.
Yeah, but novices had more of these gaze shifts during non-supportive instruction, like when they were giving initial instructions or managing transitions. So it seems like experienced teachers are using their gaze more strategically to see if the student's getting it right when they're offering support.
So it's not just about making eye contact, it's about the timing of that eye contact
Exactly.
and what it means in that moment.
Right. And Hataja and their colleagues, they took this a step further. They recorded the eye gaze of both the teacher and the student at the same time.
Wow, two eye trackers at once.
Yeah. And then they linked those patterns to how students rated their teacher's interpersonal behavior, like how warm and friendly they seemed, how in control they were. And they found a clear link between the eye gaze behavior of both the teacher and the student and the teacher's overall interpersonal style.
So those subtle visual cues, they're really tied in with the social and emotional climate of the classroom.
Absolutely. But the researchers who commented on these studies, they pointed out that neither of them directly looked at the teacher's sensitivity to student emotions.
Like, if a student's anxious or bored, can the teacher see it?
Yeah. And we know from other research that a student's emotional state is super important for their learning.
Of course, if you're stressed out, you're not going to learn as well.
Exactly. So a teacher glancing at a student's face, especially around the eyes, that could be them trying to gauge those emotions, like are they anxious, bored, interested? And this links back to Seidel's finding about expert teachers being more sensitive to students' emotional states and to Goldberg's work on facial expressions as a part of engagement. So these interaction studies are really promising, but there's still a lot to learn about how teachers use their eyes to read and respond to their students' emotions.
Yeah, it's a whole other layer of communication happening there. Okay, so let's switch gears a bit and talk about the data itself. You've collected all this info about where everyone's looking. Now what? How do you actually analyze it to make sense of it all?
Yeah, it's not just about counting gazes. The timing of everything is super important.
Because it's a constant stream of data.
Exactly. Researchers often start with global analysis, looking at overall things like how long fixations last on average,
Yeah.
or how far the saccades are.
Okay, so like the big picture stuff.
Right. But to get more detailed insights, you often use something called AOI-based analysis,
AOI.
areas of interest. You basically define specific areas that you care about, maybe the teacher's face, a section of the whiteboard, whatever's relevant to your research question.
Okay.
And then you calculate how much time is spent looking at those areas, how many fixations are made in each one.
So you can compare different areas, see what's getting the most attention.
Right. But the commentary mentioned that just looking at total fixation time on an area might not be enough
Really? Why not?
because it loses all the dynamic information. Well, did someone look at something briefly at the beginning and then ignore it? Or do they keep coming back to it?
Oh, I see. So the pattern matters.
Exactly. Measures like first pass time. That's how long someone looks at something the first time they encounter it.
Okay.
And the frequency of re-inspections or look-backs, those can tell us a lot more about how the information is being processed.
It's not just where you look, it's the whole sequence of looks.
Precisely.
What about, I think it's called scan path analysis, that's looking at this sequence of eye movements, right?
Yeah, scan path analysis takes into account both the locations that are fixated and the order in which they're fixated.
Okay.
So you can compare how similar or different the patterns are, maybe between different trials for the same person or between different people, like expert and novice teachers.
So you can see if experts have like a more efficient way of scanning the room, maybe?
Exactly. There's a study by McIntyre and Falsham. They used scan path analysis and found clear differences between how experts and novices scanned a classroom. It suggests that experts might have a more developed mental model of the classroom, and that guides their visual search.
So they're not just seeing more, they're seeing it differently.
Right. And then the commentary also brought up some interesting points about the statistics used in these studies. Like, the traditional methods might not always be the best fit for eye tracking data.
Oh, really? Why not?
Well, eye movement data often has characteristics that traditional tests like ANOVA or t-tests don't handle very well.
Like what?
For example, data points from the same person aren't really independent. Like, your attention might fluctuate in a consistent way that's not random.
Right.
And the commentary suggests that more sophisticated methods, like linear mixed models, those are often better because they can account for that structure in the data.
So it's about using the right tool for the job.
Exactly. You need tools that can handle the complexity of the data. And then there's the issue of statistical power. Basically, it's the ability of a study to find a real effect if it exists. And in classroom research, it can be hard to get large sample sizes.
Because you have to get all these kids and teachers to participate.
Yeah, and low power can mean your findings aren't very reliable. So it's important to have enough participants and enough data from each one to be confident in your conclusions.
It sounds like the field is also starting to use newer data analysis techniques like machine learning.
Oh, absolutely. Like Goldberg and colleagues, they use machine learning in their study.
I see.
These algorithms can be really helpful for analyzing these big, complex data sets, especially when we're still figuring out the relationships between all the variables. Like DeMello and his colleagues pointed out, machine learning can help us find patterns we might miss otherwise.
Can you give an example?
Sure. Liu and their team, they used a machine learning technique called support vector machines to identify literacy skills just from eye movement patterns.
Wow, that's impressive.
And DeMillo's own research has used machine learning to predict how well someone understands a text based on their eye movements. So there's a lot of potential there.
It's like using AI to unlock the secrets of our eyes.
Yeah, kind of.
Yeah.
Okay, one last thing on data analysis, the eye-mind hypothesis. That's the idea that where we look shows what we're thinking about. Right?
Yeah, that's the basic idea.
But the commentary was saying that longer fixations don't always mean deeper processing.
Right, that's important to remember. Longer fixations can definitely indicate that someone's thinking harder about something.
Okay.
But it could also just mean they're having trouble understanding it, or that they're putting in more effort to try to make sense of it. So to really interpret eye movement data, you need to validate it with other measures.
Like what?
Things that show the quality of their processing or the outcome. Like in the studies we talked about, they looked at things like students' self-reported engagement levels, how well teachers could recognize student profiles, the quality of the instruction, and even what students were saying out loud as they were working on a task.
So you're triangulating, basically.
Yeah, you need multiple sources of information to get the full picture. Okay, that makes sense. So zooming out a bit, what are the big challenges and opportunities for this whole field of eye tracking research in education?
Well, the commentary on this special issue of Educational Psychology Review, they highlighted two key challenges that are really intertwined.
Lay 'em on me.
One is, how do we take our theoretical ideas about learning and teaching and translate them into specific, measurable eye movement patterns?
Okay, so you need to operationalize your construct.
Exactly. And the second challenge is, what are the best ways to analyze all this data? What are the statistical and computational methods that will give us the most meaningful insights?
Right, because the data is so complex.
Exactly. And these two challenges are connected because the way you analyze the data depends on what you're trying to measure in the first place.
Right, right. So where do we go from here? What are some of the exciting new directions for eye tracking research in education?
Well, one big trend is moving away from studying individuals in isolation and starting to look at interactions.
Like the teacher-student pairs we were talking about.
Yeah, and also peer interactions, like the work by Hataja and Puda on teacher-student interaction and Goldberg and Rosengrant on how peers influence each other's engagement. Those are great examples. Analyzing simultaneous eye movements from multiple people is tough, but it has huge potential for understanding the social side of learning.
That's so true. We learn so much from each other, so seeing how visual attention plays into that could be really insightful.
Definitely. And another really important area is bringing emotions into the picture.
So not just what they're looking at, but how they're feeling about it.
Exactly. Goldberg's study included facial expressions, and the interaction studies, they implicitly touch on emotions, like when we talked about whether teachers can see if a student's anxious or bored.
Right, right.
And Seidel's finding about expert teachers being sensitive to students' emotions, that's also relevant here. There's this great quote from the learning scientist Art Grazer. He said that emotions are the experiential glue of learning.
Oh, I like that.
But we still don't know a lot about the specific links between different emotions and eye movement patterns in educational settings. And eye tracking could be a really powerful tool for exploring those connections.
It's like we could start to see those emotional responses playing out in real time through their eyes. That's fascinating.
Yeah, it has a lot of potential. And then there's the trend of combining eye tracking with other types of data, like physiological measures.
So even more data.
More data, yeah. Goldberg and his team, they combined eye gaze with head pose and facial expressions.
Hmm.
And other researchers are starting to integrate things like body movements, skin conductance, heart rate, even brain activity.
Wow, it's getting really multimodal.
It is, and these multimodal approaches, while they're definitely challenging, they can give us a much more complete and nuanced understanding of what's going on inside the learner and the teacher.
So it's not just about the eyes anymore, it's about everything.
Yeah, it's about seeing the whole person.
Okay, so to wrap up our deep dive today, eye tracking is proving to be an incredibly valuable tool for studying behavior in classrooms. And even though there are methodological challenges, the research we've talked about gives us a solid foundation for using visual attention to understand the complexities of education.
That's a great summary.
So for you, the listener, I want to leave you with a thought. Now that you've had this glimpse into the world of eye tracking, and you've seen how these subtle shifts in attention and perception can be so revealing, how might this knowledge change the way you think about learning and teaching? Like, how could we design better learning materials or help teachers be more attuned to their students' needs? What might you look at differently now, knowing what the eyes can tell us?
And if you're intrigued by all this, definitely check out the Educational Psychology Review and the specific research we've mentioned today. There's a whole world of fascinating research out there for anyone who wants to dive deeper.
Well, thanks for joining us on this deep dive. Until next time, keep your eyes peeled.
Uh-huh. I'll see you then.